Welcome to Lao Ming's channel. In 525 AD, Christian theologian Dionysius Exigus suggested that the year of Jesus' birth be set as the first year of the era, and the Roman Catholic Church approved his suggestion, which is the origin of the AD calendar. A strange thing happened. After the year BC, the first year AD followed, and there was no year zero in between. This is equivalent to going directly from -1 to +1 on the coordinate axis without zero in between. Why is there no year 0 AD? This is because in 525 AD, people did not know the existence of zero. Zero is the most mysterious of all numbers, and its appearance changed the way humans understand the universe. To tell the magical story of zero, we need to start from the beginning. We need to go back in time to around 450 BC. The ancient Greek philosopher Zeno suggested an idea. He said that the fastest runner is Achilles, yet he cannot catch up to a tortoise. How can someone be slower than a tortoise? Yet, when scholars gathered, none outsmarted Zeno. Zeno said, assume Achilles runs at 1 meter, while the tortoise runs at half a meter. The tortoise starts 1 meter ahead. Achilles runs, catching up in 1 second, but the tortoise moves half a meter. Achilles is fast, catching up in 0.5 seconds, but the tortoise moves another quarter meter. No big deal. In 0.25 seconds, Achilles catches up again. The tortoise starts 1 meter ahead of Achilles. Achilles starts running, and he catches up to the tortoise, but the tortoise moves half a meter. Achilles quickly catches up in 0.5 seconds. The tortoise crawls another quarter meter. Achilles catches up in 0.25 seconds. The tortoise moves another eighth meter. Achilles runs fast, but the tortoise creates infinite points. It shortens the distance. In infinite time, Achilles never catches up. Everyone knows a person can't outrun a tortoise, yet Zeno seems right. But in that split second, the tortoise moved forward another eighth of a meter. No matter how fast Achilles runs, the tortoise can always create an infinite number of points, and it creates an even shorter distance between itself and Achilles. In other words, in infinitely subdivided time, Achilles can never catch up to the tortoise. Everyone knows that it is impossible for a man to catch up with a tortoise, but Zeno seems to be right. In the river of time nearing stillness, the tortoise is always ahead. Why? This ties to ancient Greek philosophy. They believed the universe and time are eternal, existing without beginning or end, with no void. Without a void, they didn't know zero. But how does this relate to Achilles not catching the tortoise? Let's explain. The universe always exists, without beginning or end. And there is no void in the universe. Because there is no void, the ancient Greeks were unaware of the existence of zero in the world. You might wonder how not knowing about zero relates to Achilles not being able to catch up to the tortoise. Let's explain this issue. Achilles first uses 1 second to close the distance between himself and the tortoise. Then he uses 0.5 seconds to close the second segment of distance that forms between them. And then he uses 0.25 seconds to close the third segment of distance that forms between him and the tortoise. By continuously subdividing the distance and time, you create a series, 1 plus 1 to 2 plus 1 to 4, plus 1 to 8, plus 1 to 16, continuing all the way to 1 divided by 2 to the power of n. As the power of 2 gets larger and larger, the number approaches infinity, and 1 fraction of infinity will be equal to 0. In other words, Achilles' journey to catch the tortoise will actually have an endpoint, which is when they completely overlap, because there is no distance left. This position is 0, and the maximum value of the entire series equals 2. This means that Achilles will surpass the tortoise in at most 2 seconds. This is the actual result. Although the ancient Greeks did not grasp the essence of the problem, zero had already subtly hinted at its existence. However, the discovery of zero would not come until 700 to 800 years later, in the 3rd or 4th century AD. Hinduism became the most important religion on the Indian subcontinent. The ancient Indians embraced the idea that everything in the universe arises from the void. Lord Shiva is both the god of creation and the god of destruction. He embodies the ultimate void and the highest nothingness. If the universe comes into existence from nothing, how should this nothingness be represented? This is a manuscript preserved in the Bodleian Library at Oxford University, and it is one of the oldest Indian texts, known as the Bakshali manuscript. According to carbon dating, some of its pages date back to the 3rd or 4th century AD, and on one of the pages, there is a small black dot. Experts in ancient Indian languages believe that this small black dot represents zero. This is the earliest zero we have discovered so far. Nothingness needs to be expressed through spirit. Spirit does not mean non-existence. It's just that earlier humans did not realize that the form of spirit is the Big Bang that occurred 13.7 billion years ago. The universe evolved from a starting point of extremely high density and temperature which is zero. The ancient Indians seem to have unraveled the mystery of the universe's birth. Fast forward to 628 AD, the Indian mathematician Brahmagupta wrote a remarkable work, the Brahmasfuta Siddhanta, and calling this book a masterpiece is no exaggeration. It is, to date, the first work to treat zero as a regular number. In his work, Brahmagupta provided the rules for calculating with zero, a positive number multiplied by zero, a negative number multiplied by zero, and zero multiplied by zero all equal zero. These rules are the same as today's arithmetic rules. However, Brahmagupta believed that 0 divided by 0 also equals 0. 0 cannot be a denominator. Dividing by 0 is meaningless. In 1202, Leonardo Fibonacci traveled to North Africa with his father. Fibonacci saw advanced Arab mathematics. Leonardo Fibonacci, a young Italian, traveled with his father to North Africa, where he encountered advanced Arab mathematics, particularly Arabic numerals, which were more efficient than Roman ones. He learned from an Arab mathematician and discovered these numerals originated from ancient India. Fibonacci compiled his knowledge in Liber Abaci, unifying Eurasian mathematical practices. European mathematicians later understood that dividing by zero is illogical, as multiplication and division are inverse processes. Instead, it was passed down from ancient India. He wrote his mathematical knowledge into a book called the Calculation Book Zero, which finally unified the Eurasian continent. European mathematicians quickly realized that dividing by zero is a logical fallacy. Multiplication and division are essentially inverse processes. Dividing by x is essentially finding a number that, when multiplied by the reciprocal of x, will yield the same number. If such a number exists, it is called the multiplicative inverse. For example, 6 divided by 2 equals 3, and 6 multiplied by 1 to 2 also equals 3. So the multiplicative inverse of 2 is 1 to 2. Similarly, 40 divided by 5 equals 8, and 40 multiplied by 1 to 5 also equals 8. So the multiplication inverse of 5 is 1 to 5, which means that any number multiplied by its multiplication inverse equals 1. If we want to divide by 0, we are essentially looking for its multiplication inverse 0.1. Letting 1 0 multiplied by 0 equal 1, but we know that any number multiplied by 0 equals 0, so 0 cannot have 1 0 as its multiplicative inverse. Therefore, 0 cannot be a denominator. Having 0 as a denominator is a violation of logic. Now we arrive at the year 1425. The famous Italian architect Brunelleschi painted a strange picture. No one had ever seen a painting like this before. The space in the painting seems to converge towards a single point. The closer you get to this point, the further away you feel from the observer, and the degree of compression increases. If this point is far enough away, everything, land, oceans, even planets and galaxies, can be compressed into this zero-dimensional point. So, this point is not only zero, but also infinite. In today's art, this point is referred to as the vanishing point. Before Brunelleschi painted the vanishing point, all paintings were flat. For example, in this painting of the Crusades, there is no sense of perspective. The mounted Crusader leader and the castle appear to be about the same size, while the archers on the castle look like little dwarfs. These are all flat, distorted, two-dimensional images. There's a very interesting story related to the vanishing point, involving a German bishop named Nicholas of Cusa, who was a contemporary of Brunelleschi. He spent a long time observing the night sky, and ultimately came to a conclusion. The Earth is not the center of the universe. How did the bishop arrive at this astonishing conclusion? Because he did not see any vanishing points in the universe. Brunelleschi's painting made European mathematicians realize that there seemed to be a void in space. Europeans continued to explore the relationship between zero and infinity through geometric perspective. In 1854, the brilliant mathematician Riemann gave a lecture at the University of Göttingen. Sphere projects onto negative plane, south pole at 0, shadows cast from north pole, poles points don't map to 0, circles not through poles stay circles. You can project a sphere onto a negative plane, aligning the south pole of the sphere with 0. If you place a light source at the north pole of the sphere, all the shapes marked on the sphere, like circles, will cast corresponding shadows on the plane, with the exception of the two poles. The projection of a circle that does not pass through the north and south poles remains a circle. The most interesting thing about the North Pole is that the projection of a circle passing through the North Pole onto the plane is a straight line, because a straight line has no end, indicating that the North Pole is actually infinite. There's something even more interesting. If we replace the numbers on the x-axis with their multiplicative inverses, it's like multiplying by 1 over x. This mapping of 1 over x is called the entire spring function in mathematics. At this point, the sphere flips upside down, as if reflected in a mirror. The North Pole becomes the South Pole, and the South Pole turns into the North Pole. 0 becomes infinity, and infinity becomes 0. In other words, 1 over infinity equals 0, and 1 over 0 equals infinity. Riemann defined the infinite point, and strange things happened again. 1 over 0, where 0 actually becomes the denominator. It is thanks to Riemann's contributions that humanity was finally ready to peek into the hidden secrets of the universe. Fast forward to 1915, the year when Einstein published his general relativity, which is mathematically based on Riemann's set. Just a few months later, a German physicist named Karl Schwarzschild calculated the first exact solution using Einstein's equations. This formula looks like this. Schwarzschild discovered that when r equals 0, this formula produces a starting point of 0, once again making it a denominator. At this point, the curvature of space-time diverges infinitely. Schwarzschild suggested that there might exist a magic sphere in the universe where anyone passing through it would be instantly pulled in by gravity, and even light could not escape. This was a peculiar celestial body predicted by humanity through mathematical calculations, and this body is called a black hole. In 1915, the existence of black holes was unimaginable. Comedian Stephen Wright wisely remarked that black holes are where God divided by 0. In a black hole, physics and time cease to exist. Approaching the starting point increases space-time curvature towards infinity, creating a void. A black hole's mass is immense, but occupies no space, making it a paradox. 0 becomes illogical in the denominator, thus existing at 0. Scientists predict the universe's end between 1040 and 10100 seconds post-Big Bang, leaving only photons and supermassive black holes to maintain galaxy structure. No planets remain, only various sized black holes, marking the black hole era. These black holes merge, producing light when consuming each other, ensuring light persists. Over time, black holes evaporate via Hawking radiation, eventually disappearing. Scientists believe that the universe may have an end, occurring between 10 to the power of 40 and 10 to the power of 100 seconds after the Big Bang. At this point, only photons and the supermassive black holes at the centers of galaxies remain, continuing to maintain the structure of galaxies through gravitational effects. However, this time, there are no planets in the galaxy, just a multitude of black holes of various sizes. The universe has entered the black hole stage, or the era of black holes. These black holes will continue to merge. Today, we have observed that when black holes consume one another, they produce a significant amount of light. So, even in the black hole era, there is still light in the universe. However, as time goes on, black holes will slowly evaporate through a phenomenon known as Hawking radiation. There will come a day when the last black hole no longer exists. 101 seconds after the Big Bang, as the universe expanded endlessly, the temperature in space approached absolute 0, and photons could no longer move in space. Finally, even photons disappeared, leaving only endless cold and darkness. The end of the universe is endless space, and the terrible thing is that there is no matter in it. This is a real era of emptiness, which scientists call the era of the Great Nirvana. The universe began at 0, but ended in infinity. 0 and infinity seem to answer the fate of the universe, but this result is very difficult to understand. Why does mathematics always guide the world we live in? Or we can change the way of asking questions. Why is the universe computable? As Einstein said, the most incomprehensible thing in the world is that it is understandable. This is the most terrifying question. Why does the universe spare no effort to let us understand its logic and structure? In this vast and ever-expanding cosmos, we often find ourselves pondering the mysteries of where exactly the universe is attempting to guide us. It's a question that has intrigued humanity for centuries, and while we may not have all the answers, it's a journey worth exploring. As we wrap up today's enlightening program, we hope you've enjoyed the insights shared and the questions posed. Remember, this is just the beginning of our exploration together. Don't forget to subscribe to Lau Ming's channel for more thought-provoking discussions and fascinating discoveries. We look forward to having you join us again in the next episode, where we'll delve even deeper into the wonders of the universe and continue our quest for knowledge and understanding.